All right, we're going to do something a little bit different, and this is three-dimensional graphing. The challenge is we're trying to portray 3 dimensions on a what dimensional paper? 2-dimensional. Okay, so it's a trick. Now, you artists are able to do that. What you need to realize is that on 2 dimensions, you're going to have 2 axes, and then you have one coming straight out at you. And if you look at it head on, you really don't see anything. It's just coming straight at you. So we have to look at it from above, and you end up, this piece that's sticking straight out at you, we'll put it at an angle here, coming at you. And then we've got section going in the back. So the challenge here is that with 2 dimension, you have X going this way and Y going up and down. For some reason, the author decided to have Y go left and right, and then Z goes up and down, which leaves X to come straight at you, and then going backward. Now, just like with the X and Y axis, we usually label the X and Y axis here with 2 dimensions. This is in the positive direction, and this is the positive direction. So likewise with 3 dimensions, this is going to be the positive direction, and which way is going to be the X positive direction? Toward you or away from you? Toward us, because it's labeled right here. So that's the positive direction coming straight at you. And I know that might be confusing because you're saying, oh, this is going up. Well, it's actually going backward into the next room next door. All right, what we're going to do is we're going to graph in 2 dimensions, and then we're going to graph in 3 dimensions. So let's go ahead, graph in 2 dimensions a straight line here, 2x minus 3y equals 12. A quick way to graph it is to plot the 2 what? Yeah, the intercepts, the x and y intercept. The x-intercept in this case is 6, and the y-intercept? -4, you got it. So here's 1, 2, 3, 4, 5, 6, and the y-intercept is -4. And then we connect the 2 with a straight line with arrowheads, 2 points to determine a line. We're going to do something similar when we go to 3 dimensions. You're going to find you have an x, a y, and a z intercept, and we're going to plot those and then connect them. So what's the x-intercept? X-intercept, y and z are 0. It's 3, good. And the y-intercept, okay, the x and z terms become 0, so this is 4, good. And then the z-intercept, good, -6. Now what I'd like you to do is I'd like you to plot what I call the footprints. When you count this in the x direction, 3, mark it, 1, 2, 3. It turns out to be on the x-axis. The y-intercept is on the y-axis, 4 units to the right, 1, 2, 3, 4. And then go ahead and tell me where to go for the z-axis. It's a -6. Which way, up or down? Down, yeah, it's in the negative direction. So z-axis, 1, 2, 3, 4, 5, 6. And what do we do with the 3 dots? We're going to make a what? It looks like a triangle, but it's actually a what? It goes on forever. So what is it? It goes in 3 dimensions. A plane, you got it. It's actually a plane, but we only see a part of it. So let's go back to space. In space, if I slice space like this, I have space above and I have space below, so I have 2 areas. If I cut those 2 areas in half again, I've got how many areas? 4. And what if I cut those 4 areas in half again? How many areas am I going to have? 8, yeah. Now, in 2 dimensions, we called these 4 what? Quadrants. And in 3 dimensions, we're going to call each area what? There's 8 of them, so we're going to call them quadrants, octants. So we have 8 octants. So, got a question for you. This plane goes on forever, but we only see a portion of it. Which octant are we looking at right now? This triangle is actually cut off by each of the 3 planes. Okay, let's go back. This plane right here is being cut off by the 3 axes planes. So where is that plane sitting? This triangle. Explain the octant. Is it in the front or the back? Okay, so in the x-axis, it's in the front. In the x direction, we're coming out front. So it's in the front. So it's like it's in this room as opposed to Miss Lee's room. Okay, so it's in the front. Now, the y-axis, is it going to the right or left? The right. Okay, so we got front, right, and now what's the 3rd dimension? Bottom, because it was what kind of a z? Negative. Okay, so it's front, right, bottom octant. A linear equation of the form x, y, z equals d represents a plane.